to shoot a quick video how to use the exponential functions with your calculators. So I thought I'd just show you what it looks like on the calculator, and then do a couple of questions out of the homework just so you have some feel for putting all this stuff together with the calculators in this new function. So let me switch over to the calculator screen first and show you where that stuff is. Okay, so this is, the front screen or the main screen of the calculator. If you need to do any kind of exponential function, the idea is the inputs go up into the exponent. So if you had a function like 3 to the x and your input for x was 0.05 or something, you have to hit your base, and then you would hit this little exponent key over the division sign, and then that's where you would type in your exponent and then hit enter, and it evaluates it over here. Now, a lot of our bases in this particular set of applications is based on either things as they grow or change exponentially in nature or financially. And the base of those a lot of times is this mystery kind of transcendental number called E. And it's kind of like the number pi, where pi always shows up when you're doing some kind of a circle or round thing, all the formulas have pi. Well, this E shows up a lot of times when you have exponential growth or decay, especially in nature. So if you just want the E button, it's above the division symbol, but typically we're putting exponents on the E. So down here in the lower left-hand corner of your calculator buttons, 3 up from the bottom on the far left, it says E to the X. That's where you want to go when you need to calculate some exponent on the E. So since it's over the ln, that's going to be our natural log. We'll learn about that later. So if we want to do e to the 0.05, say, we have to hit our blue second function button first to get the e to the exponent to pop up, and then you just simply type in whatever exponent you're dealing with. Okay, so e is a number I'll show you what it is. I'll just hit E here, and then when I hit enter, it will show it in decimal form. E is a value that's just a little bit less than 3, 2.718. Just like with pi, which is a little bit bigger than 3, we throw in 3.14 when we're wanting to get an estimate. Well, E is a little bit less than 3, so we kind of throw out 2.72 if we have to do a quick calculation, when we don't have the E button. But all of us have E buttons on the calculator here. And also, if you're using the calculator on your cell phone, if you turn it sideways, I don't know if you know this, when you've got the calculator open, then a whole lot more buttons that are available to you pop up, and one of those is the E to the X button. So you can also use your cell phones. I think on those calculators, you have to type the exponent first and then go get that E to the number that you have just typed in. It'll use that as the exponent on E and display the answer. But anyway, we're on the calculator, or graphing calculator. So this is how that works. So if you wanted to go and graph E to the X, as a function where you have an x in there, or e to the 0.5x or something like that, you go get that e to the x symbol, and then you put in your whatever the function is. The x will be up in the exponent because that is the main property for exponential functions. Okay, I'll stop talking about the theory so much because you've got another video lecture I posted on that. But if we do that, and I'm just going to go back to the middle graph, zoom 0. No, I messed up. Oh, because it's e to the 0.03x. That makes it increase very slowly. So let's see, if I wanted to do x max out to maybe 100, we'd start to see that it does increase, but it takes a lot longer. So it's increasing a lot slower when we have that 0.03 up in the exponent. Anyway, let me go and look at one of the homework questions. So let me stop sharing this and go to the homework for this section. And I'm going to look at, I picked, I think, number 9 because it's got some graphing in it. Okay, so they give us this function up here. It's in a word problem. It's about an investment that's compounded continuously. So that's why we see the E as the base down here. The variable C is T, and it's over the E. So if we wanted to choose the correct graph, I'm just going to match it on my calculator. I know when you go to the question helps, it has you fill out a chart first and then kind of figure out what the chart of values does help you to figure out how to set your window settings. But I'm going to be kind of lazy since all 4 of these choices have the same window settings. I'm just going to use that and put it in straight into my calculator. So X runs from 0 to 15, and Y runs from 0 to 34,000. And I'm going to type this part of the function, like the S is where the Y would be. I'm going to type 5,000 e to the 0.09. And I always have to use X in the calculator, even though it says T here. So let me switch off this and go back to, let me write that down so I don't lose it. So 5,000 e to the 0.09 T. My document camera is not working at the moment, so I'm having a difficult time trying to show you on paper how this stuff works, but a lot of this is calculator stuff anyway. Okay. By the way, this means that you had an initial investment of $5,000 and it's growing at an annual rate of 9%. So those numbers actually have meaning. Okay, so let me get off this. Sorry. Stop sharing that. And then begin to share the calculator again. I wish I could display both things at the same time, like on a split screen, but I'm not that good at Teams yet. So, all right, so let me go over here. I'm going to put the function in. So it was 5,000 e to the 0.09 t. Now when it's the base is e, you don't have to put any kind of multiplication symbol in there. The calculator understands that means multiplication when you write something, two things side by side like that. All right, so that's to 0.09 t, but I had to change the t to x. So this is going to calculate the value of that investment, and x is however many years after that investment was begun. So I'm going to go and look at the graph. So I'm going to remember it said all of those pictures, it ran from 0 to 15. So we're looking at a 15-year investment. And then the Y value just started at 0, but it went up pretty high to $34,000. Okay. It doesn't really matter on the scale, but I think I'll let I don't care. I'll let it go by, doesn't matter. I can't stop myself. All right, let's do it by 10,000s. And there'll just be like 3 marks on there. Okay, so I'm going to hit the graph, and that's what we've got. So this value over here has a height of 5,000 because that's where it starts, and then it's growing because the exponent was a positive 0.09. So the exponent, let me hit trace so you can see the function here. The sign of the exponent can tell you whether it's increasing or decreasing, kind of like slope does for a line, as long as your base number, which is e right here, is a number that's greater than 1. So as long as your number is greater than 1 down here, the sign of the exponent up here will tell you whether it's increasing or decreasing. So that's what it's supposed to look like. It's increasing, kind of concave up a little bit, and it starts at a height of about 8,000. So now we need to go and match that to one of our graphs. So now I have to unshare and reshare again. Unshare, share the homework. Okay, so these are our 4 choices. So we can eliminate the 2 that are decreasing. Oh, there's only one. Yeah, the last 2, C and D, are decreasing. So it's got to be one of these first 2. And if you just kind of estimate, I'll break out this first one here so we can kind of see. Remember the starting amount was 5,000, and this looks like that kind of lines up with 5,000. So it's probably this one. But let me break out the second one and just verify that. Yeah, see how this is at 8,000. So this one starts at less than 4,000. So this one starts too low. So remember the y-intercept on this corresponds to that big number that's sitting in front of your base number. So our correct graph is going to be this first one. So I'll hit the answer. Well done. Okay. Now, this is where I wanted to show you remind you of some solving and intersection techniques on the calculator. Now, when it says use a graph to estimate when the future value will be 8,000. Okay, so they're not giving us the easy part. They're not saying, hey, how much is it going to be worth in 4 years? And you plug the 4 in for the t and just type that into your calculator. They're doing the opposite thing where they give you an answer and they want you to somehow work backwards. Now, normally we would be solving that equation for t. We would take this function and put the 8,000 over here and solve it for t, but we don't know how to do that yet in this section. So we're just going to do it by graphing and using the intersect feature. So what we'll do is we'll take that graph that we have on our calculator and we'll find out where there's a height of 8,000. Remember, it starts at 5,000 So we're going to find out where 8,000 is and just draw a line that's at a height of 8,000 across our graph and figure out where it hits that graph. So let me do that. Go back to our calculator. There we go. All right, so I'm going to go into the calculator and put the answer they're asking us about, which is $8,000, in as a separate function. And when I graph this, since there's no x, it's just going to shoot a horizontal line across my graph like that. And now I'm going to use the intersect feature. This is a very good way to get an estimate for an answer that you're trying to find. If you want to get really exact or have it rounded out to 6 decimal places, then we'll use our solving techniques we're going to learn later. But for a rough estimate, the intersect feature works as long as you can see the intersection point. So I'm going to go through this intersect thing pretty quickly because we've already had this in a video and you can always go back and look it up. But you tell it yes, y2, y1, y2, the yes, I can move it over there. But here's the answer. We have an intersection. We know that y is 8,000 because every point on that red line is 8,000. But where it intersects the blue function, which is what we're interested in, is at an x value of 5.2222625. So that is the answer that they're looking for. This is after how many years is it going to hit 8,000? Well, about 5.2 years after the start of the investment, that $5,000 will have grown to $8,000. So let's remember 5.22222. So let's go find that one. Okay, so I'm looking for 5.22, which is answer C. In this particular example. And then we get on to a chart. They're going to have us fill in a bunch of numbers from the chart. So again, when they give you the dollar amount, that's the output, and they want us to find the input, we're going to do the same thing with the intersect. We'll put in this number, 17,627.11, in for Y2 and run the intersect feature. I tell you what they are doing here. Since we're talking about the table, maybe I'll show you the table to see if that's something that might be a little faster. None of this is real fast because I have to keep switching back and forth. So let's see, I'll go and show you that. Now the example that I just did was using the intersect feature. When they gave us an answer, I took that output and I put it into Y2, and then we looked at the graph and found where it intersected. There's another feature or another area of this calculator that doesn't look at the graph, but once you have a function entered in here, let me go down and clear this one out because that was just for a particular problem. This is the function we're dealing with. You can actually have the calculator make a table for you, and it will show you the outputs, or you can go through and find the inputs. So the table is above graph. So let me just try that. And let me see. Okay, the way this one is set up, it's set up to automatically calculate the x values for you. So when it's in this version, you can just use the up and down arrows to scroll anywhere you want to, and find, whatever whole number value for x you're looking for. What it's not so good with when it's in this section is what if we wanted to know what the function's value is when x is 2.5, because that's not in our list. We have to type that in ourselves. So if it gives us an x value that's not a whole number like this, then we might have to change the setup on our calculator. Let me show you what the setup is that this one is. So table setup, if you want it to look like this, we can just look back and forth in the answers. Again, the blue second function button. This is all, again, in the videos. You want independent and dependent to both be set on auto, and you want the delta or the increments on the table for x values to be 1. It doesn't really matter where you start the table because you're going to be able to scroll up and down, but we want the increment of the x values to increase, or the units, by 1, and everything set on auto, which is what this is. So again, if we go to the table, I believe, was the value like 17,000 and something? Let me look and see if I see one that looks kind of like that. Maybe this one. One of the things about the tables, if you actually put the cursor on the value, you'll see that you get a lot more accuracy down here than what it's able to display up here. But I think it was this 17,000 thing. Let me go look at it. I don't have to change the window for me to look. It said 17,627 and about 11 cents. So that's this one. So we can actually just scroll through the table. and then look over and say, oh, that's at 14 years. And then that would be the answer to that question. I wouldn't normally do another one, but I believe I'm gonna, on this table, what did I say it was? 14? Did I say 14 years? Let's see, 14. Well, let me go look. I can look and see. Yeah, 14 years. I'm gonna enter that. Oh, I did a good job. I feel so good. And I think they just keep doing, oh, okay. And then here they're giving you, this is the easy part. They're giving you 10 and 20. So you're just going to plug these numbers in for the x into the function like you have all semester. So there are a couple of ways to do that. So let me show you that, and then we'll be done. So let me see. We've got all right. So the first one they asked about was when x is 10. So I just want to show you two ways that you can do this. If you're already looking at the graph, which we are here, and we know that x goes from 0 to 15, and 10 is in here somewhere. As long as you can have the x value showing on your graph, the trace feature is probably the fastest way, because when you hit trace, it shows you a particular ordered pair, but you can type in any other x value you want, and it will calculate. When you hit enter, it will calculate the y value for you. So I want 10, so I'm going to type 10 and then hit enter. Okay, so you have to remember to hit the trace button before you do that. Like when you hit graph, this is all you see. You just see the picture. But if you want to see what function you're working with and be able to type in values to estimate things, then hit trace and it will add to that graph. It'll put a cursor on your graph, tell you where that cursor is located down here and which function you're working with. And you can type in whatever other x value you want. And it's waiting for me to hit enter, and then I can find the other value. All right, so the first part of that question, it asks, what's the output when after 10 years? Just use trace, type in 10 if you want, and then round this to whatever they say. However, the second value they talked about was when x is 20. Now remember, our viewing window on the graph only goes out to 15, so it depends on, unless you have a really nice calculator, but I don't think this one will work. But let me try. If I type in 20, it may give me an error message because it can't see that graph, or that point on this part of the graph, because it stops at 15. Yeah, it says it's not that it isn't valid. It's just that we aren't seeing it on the window. So it doesn't like the fact that the 20. It doesn't like the 20 because it's too big and we only can see out through 15 on the x-axis. So of course you could always just go to the window and increase your x max out to 20, and then that would work. But you could also just go to that table we were just looking at there and just scroll it down until you hit the x value over here of 20. So if you have the table, now here's our answer. Let me scoot up there. That's our answer. Notice if I need the pennies, if I need more detail than this, I look down here. So you have to highlight the answer, $30,248.24, or however they want you to round it. So you can use the table if it's set to automatically calculate the integer values for x. You can get your answers out here. You can also go to the graph, and as long as your x value is somewhere between the x min and x max, you can just hit trace and type in, I'll type the very last possible value, which is right at the far edge over here. I can type anything between 0 and 15 in here. This also allows you, if you're on this kind of a screen, to type in numbers that are between the whole numbers. Like you won't see 2.5 on that table because it jumps from 2 to 3, but you could put a decimal estimate of an x value in on the trace screen and it'll give you a good estimate. So that's how the calculators can work with using the exponential function. So remember the e to the x button is 3 up from the bottom on the far left, but it's over the button. So you have to hit second e to the x to get it, and then you can type in whatever you like. So I hope that helps just a little bit with getting to know 5.1. I know some of you are behind on it because you were struggling a bit with that content. So hopefully this will help you kind of get back on track. And I have also posted, as I said, a bunch of videos and a couple of activities that a couple semesters ago, there was a class that was struggling with this. So I made up some videos for that particular module. Okay, so keep working. You're doing a good job. This module needs probably extra time to get through everything and feel comfortable with it for the time of the test. Okay, so have a good day. Bye.